Dear friends, please subscribe yo.com and press the bell button for recent updates. Thank for watching.
Welcome students. So in this session we are going to see the unit 5, that is interfacing microcontroller. So in unit 3 we were studied different interfacing ICs. So that is a 8254 timer and 8251 serial interfacing controller, then 8255 peripheral interface controller, then 8279 keyboard display controller, okay, then DMA controller, interrupt controller. These are the different interfacing ICs we have studied in unit 3. But here the interfacing means how to connect different device with 8051 microcontroller, how to connect stepper motor, how to connect keyboard, how to connect LCD, and how to connect ADC, DAC, etc. So according to the requirement, what are the interfacing are available with 8051 microcontroller and how to connect. So these are things we are going to study in unit 5, that is the interfacing microcontroller, interfacing of 8051 microcontroller. Okay, let us enter into session.
u.com.
So first topic of unit 5 is the timer. 8051 timer. What is timer? Already we studied the timer. Okay, that is the timer presents 8254. So Intel 8254 is a timer IC that is used with 8086 microprocessor. Okay, but in microcontroller 8051, the IC itself has timer. It has two 16-bit timer. So here we are not going to study 8254. Here we are going to study the timer present along with 8051 chip. Okay, right. So the timer that is present inside the 8051 chip, we are not in outside. So what are the different type of timer and modes, then how to program? These are the things we are going to study in this session. So first topic is the timer or counter. 8051 timer or counter. So the timer has oscillator. Okay, actually the oscillator that generates the frequency. The 8051 has crystal oscillator. The crystal oscillator generates frequency. That frequency is given to 12 divider. The given input frequency is divided by 12. For example, the crystal oscillator frequency is 12 MHz, means that is converted into 1 MHz in timer circuit initially. Then that is given to one switch, that is a C by T for whether it is act as a counter or act as a timer. So this switch is connect with the register, timer register TL and TH. Okay, so this register is to store the count value. Okay, 16-bit count value. So we can store the 2 8-bit also. Okay, so it is divided into 2 8-bit. So the consider the T mode register, that is a SFR. We were studying the T mode in special function register, that is a SFR. So here in the T by C by T bar, that is equal to 0 means that is it is act as a timer. If it is 1 means it is act as a counter. What is the difference between timer and a counter? Timer is produce time delay. Okay, timer is produce time delay according to the count value loaded in count register. Counter means counter is to count the pulses coming from external device. Okay, so counter count the pulses, timer generate the time delay. Okay, right. So whether the device is act as counter or timer, that is decided by the single pin or single bit T mode register. Okay, C by T. Actually here we are having the two timer 0 and timer 1, so that we are having the separate C by T is present. Okay, the control signal is separate for this T1 and this is for T0. Okay. Next one, TCON register, that is a timer control register. The timer control register has two flag register, that is a timer flag register. So TF0 and TF1. TF0 for timer 0, TF1 for timer 1. Okay, so when the count value is overload, count value is became 0. Okay, actually initially in the count, for example, the count value is 10, means it is decreased to 9, 8, 7, like that. When it is reaches to 0, at the time the TF equal to 1, it generate the, it indicate the flag. So it indicate the timer is the count value is become 0 and it is overflow. Okay, right. If it is 1, then it is act as a counter. Okay, so counter needs different signal, that is the counter means it produce we can connect external clock signals. So the T pin is connected with the switch and it is controlled by the this AND gate. The AND gate input is OR gate and TR. TR is a timer run. It is a single bit that is controlled by a program, so we can run the timer by using TR bit. Then after that the gate pulses. The gate is used to switch on and off the timer, that is by using a NOT gate we connected with R. Then another one is a INT pin, that is a interrupt pin. Okay, right. So timer run and timer flag also present here. Okay, so gate is used to switch on, switch off the timer. So this is a 8051 timer. The timer consists of oscillator, then dual divider, then timer register, that is a section bit, then timer flag register that indicates a timer status. Then the timer is controlled by two things, one is C by T bar and gate signal. Okay, if it is act as a counter, it will count the external pulse. If it is act as a timer, it will get the clock from the crystal oscillator. Okay, right. The gate is used to switch on and off the timer, and the timer run is used to run the timer. Okay, right. Then the output of flag register is connected with the interrupt, so it will generate some interrupt. Then T mode register. So already we studied the T mode register. So T mode register is to indicate the different modes of timer. Actually here we are having a two timer, timer 0 and timer 1. So each timer we are having the 4 bits, one for gate, then counter or timer, then mode value M1 or M1. Okay, so we'll see the mode. The gate is used to enable or disable the timer. When is set, the timer counter is enabled. Okay, if not set, okay, that is disabled. If INT X bin is high, then TR is set, timer run is set. Then when the gate is cleared, the timer run is enabled if TR bit is set. Okay, so timer is enabled when timer run bit is set, and after that C by T bar. So when it is 1, the counter operation is takes place. So the counter gets the input from external device. When it is 0, it is act as a timer, so it gets the clock from internal clock. Then two modes are available. So T mode byte is not addressable, so this is a modes of operations. So mode 0, that is 00 means it is act as a 8-bit timer. TL serve as 5-bit prescaler. Okay, that is a 8-bit timer, and the remaining TH act as a 3-bit prescaler. If it is 0 1 means it is act as a 16-bit timer or counter. TH and TL are cascaded. No prescaler is used in 0 1. 10 means it is act as a 8-bit auto reload timer or counter. TH content loaded into TL value when it is overflows. Okay, TH content loaded into TL when it's overflows. If it is 1 1 means TL 0 is a 8-bit counter controlled by the timer 0 control bits. TH 0 is 8-bit timer controlled by the timer 1 control bits. Okay, so that is a 2 8-bit timer. Okay, so these are the different modes used in 8051 timer. This is a T mode register functions. Next one you want to see the TCON register. TCON means timer control register. So here it has four different lines. One is TF1. TF1 means timer overflow flag. TF1 or 0. Okay, TF timer overflow flag set by hardware on timer or counter overflow, cleared when CPU vector to interrupt service routine. Okay, so the timer TF flag is used to indicate the timer is overflowed or not. TR, the TR is used to run the timer, okay, or switch on and off the timer. IE is used to, that is a interrupt flag set by hardware when external interrupt edge detected, cleared when interrupt processed. TIT, that is a interrupt timer interrupt. So this is also control bit set or cleared by software to specify falling edge, low level triggered external interrupt. Okay, so this is a TCON register. TCON register consists of 4 important control. One is timer flag, timer run, then interrupt enable, then timer interrupt. Okay, these are the 4 different signals used in TCON registers. Then modes. So the 8051 timers are divided into 2, that is a timer 0 and a timer 1. Timer 0 has 4 modes, timer 1 has 3 modes. So we will see the one by one. First one, timer 0. This is a timer 0. Okay, next you will see the mode, timer 0, mode 0. In mode 0, the timer 0 acts as a 13-bit timer or counter. So it has 13-bit register. The 13-bit binary values are loaded into the register. Okay, then the TF flag is set when the register value is overflow. Okay, this is a mode 0. Then mode 1. In mode 1, the timer 0 acts as a 16-bit timer or counter. So 2 8-bit register is used here. So we can store 16-bit data in the registers TH and TL0. So maximum count value is FFH. Okay, so we can load 16-bit count value to the register. TF is a timer flag register that is used to indicate the timer overflow, that is given to interrupt controller. Then mode 2. So it is a 8-bit timer or counter with auto reload. What is auto reload? Whenever TL0 become overflow, at the time the TH0 value is loaded into TL0, so automatically the timer start again. Okay, here the maximum count value is FFH, that is a 8-bit, that is a mode 2. Next one is a mode 3. So in mode 3, the timer 0 acts as a 2 8-bit timer or counter. So this is the first one. The first 8-bit timer or counter is controlled by the timer 0. So this is a second 8-bit timer or timer or counter that is controlled by timer 1 control. Okay, so it is acts as two separate 8-bit timer or counter. So we can give different input to this timer or counter. Okay, right, this is a mode timer 0 mode 3. Then this is a timer 1. So already you studied this diagram. Okay, timer 1 mode 0. So in timer 1 mode 0, it is acts as a 13-bit timer or counter. Okay, as usual in timer 0, as like it's timer 0. It's a 13-bit timer or counter. TH is a 8-bit, TL is a 5 bits. Totally we are having a 13-bit. The 13-bit values are loaded into this register. Okay, then timer 1 mode 1. So in this case the timer 1 is act as a 16-bit register. So it can load 16-bit data to the register. This act as a counter. So the 16-bit data is became overflowed, that is indicated by the timer flag register. Okay, so this is a timer 1 mode 1, and timer 1 mode 2 is 8-bit timer or counter with auto reload. The mode 2 is a auto reload mode. So whenever the TL value become 0 or overflow, the time TH value is loaded into TL. So to continue the counting or time delay generation. The maximum count is FFH, that is a 8-bit. These are the different modes of timer 0 and 1. So the programming of timer. So here in order to program the timer, we are consider T mode register and TCON registers. These two registers are very important. Okay, so example, indicate which mode and which timer are selected for each of the following. Okay, so move T mode comma 01 H, move T mode comma 20 H, move T mode comma 12 H. So T mode register is a register, it's a 8-bit register. So this register is to select different modes. It has a gate and a C by T bar and more. And this T mode register is to control the modes of timer 0 and timer 1. Okay, so if T mode equal to 01 H means that is this is a solution. The mode 1 of timer 0 is selected. If it is 20 means second input, mode 2 of timer 1 is selected. Okay, 20 means there is a mode 2 timer 1. So lower 4-bit allocated for timer 0, upper 4-bit allocated for timer 1. Then here mode 2 of timer 0 and mode 1 of timer 1 are selected. For the data is 12. So the data is 12. So that indicates the mode 1, mode 2 of timer 0 and mode 1 of timer 1 are selected. Okay, so this way we can program the timer. Then one small problem, find the timer clock frequency and its period for various 8051 based system with the crystal frequency is 11.05 MHz with when C by T bar bit of T mode is 0. So C by T bar equal to 0 means that is acts as a timer. Okay, so initially the timer divide the crystal oscillator frequency by 12. So that is happened here. So 1 divided by 12 into 11.0529 MHz, that is equal to 921.6 MHz. Then T equal to 1 divided by this time period. Okay, this is in frequency. To convert the frequency in time, we have to divide that value by 1. 1 by the particular value. That means we are inverse the value. Okay, taking the inverse. So the time 1.08 microsecond. This is the time of the given in data is present in the above problem. Right. So before that, before completing this session, we have to see some problems that is available in our book. Okay, so just open your book and take page number 5.2. Here one problem is there. So write ALP to generate square wave of 50% duty cycle on pin port 2.2. Timer 0 is used to generate the time delay. Crystal frequency is 11.05 megahertz. Okay, so the objective is to write the ALP to generate the square wave at 50% duty cycle at port 2.2. Timer 0 is used here. Okay, crystal frequency is also given. And first, what we want to first draw the block diagram. Initially, we are load the T mode value, that is a timer 0 and mode 1. Then load the initial value into TH and TL register. Then that produce the toggle in port 2.2, that is a waveform. Then called delay subroutine. Toggle means high and low changes. After that, we are calling the delay subroutine. After delay subroutine, this loop is continuous again and again, so we will get square wave continuously. Okay, delay subroutine that is present here. So start timer 0, mod the timer 0 flag until rollover. If it is GF equal to 1, then stop timer. If it is no, means it's continue again, or monitor the time 0. Then after, if TF equal to 1, then stop timer, then clear T0 flag and return. This is the algorithm of or flowchart of given objective. Then the solution, here we are writing the program. Initially the T mode's value equal to 0 1, so that is a timer 0 is selected. Okay, and mode 1 is 0 1 means mode 1 is selected. Then move TL0 equal to 0F to H. TL0 is a timer register lower byte. In that you are loading the count value F to H. Then move TH0 equal to F of H. TH0 is a higher 8-bit register of timer 0. Then complement port 2.2, that means initially we are nothing sent to port 2.2, so initially just we are complemented 2.2, then we are calling one delay, then yes jump loop 1, then the delay, after the delay completion, so this loop is again continued. Okay, right, so this is the one set. Then after that the delay program is present here. So the main program is completed by this instruction. Here the delay program is start from here. So set timer register 0, then jump no bit TF0, that is a loop 2. We are checking the timer flag register 0. Is there any bit is present or not? If not, you are waiting for the bit. When the bit is received, this loop will break. When TF equal to 1, the loop 2 is break, then it will execute the clear timer 0, then clear timer flag 0 and return. Okay, right, so this is the program for generating the square wave, okay, at port 2.2. Here we are having some calculation. Initially the timer is divided by 12, incoming frequency is divided by 12, that is a 9.21 kilohertz. Then this is the frequency, then the frequency is divided into time, so that is by using this instruction. So the time t equal to 1.08 microsecond. Then next we are going to calculate the count value. The total count is ff. Okay, so in that it just subtract ff2. What is that? That is a 0D, the decimal, and 1 to 13 to because of the extra clock needed when its rollover from FF to 00 and raise the TF flag. So time delay for half pulse, that is a 50% of duty cycle, that is equal to number of count into 1.085 microsecond. Number of count is 14. We are adding a 1 with 13. Okay, right? Then 14 into 1.085 into that is equal to 15.19 microsecond. Okay, so total time delay generated by timer equal to 30 microsecond into 15.9 30 microsecond. The another one program, write a ALP for timer 0 and create a pulse with of 5 millisecond on port 1.4, crystal frequency 11 MHz. Here we are going to write the program for timer 0 to create the pulse width of 5 millisecond in port 1.4. In port 1.4 we have to generate the 5 millisecond pulse width. Okay, right. Initially crystal frequency is 11.05, that is divided by 12. This is the actual clock frequency, and that is converted into time, that is 1.085 microsecond. So number of clocks for 5 millisecond equal to, so 5 millisecond, 5 into 10 power minus 3 divided by t, that is equal to 4608. So that is converted into hexadecimal, that is 1200 hexadecimal. Okay, then initial value that loaded into THTL register equal to, so that is FFFF minus 1200H, that is equal to this value plus 1, then EE00. So the EE00 that is loaded into register, timer register. So the 00 is lower 8 bit, that is loaded into TL register. E is higher 8 bit, that is loaded into TH register. Then after that we are programming the timer. Initially we are clear port 1.4, then moving the T mode value, T mode register as 01. So it is set to timer 0 is enabled here, then there is in mode 1. Then here the loop is started, move TL equal to 00 H and move TH0 equal to 0 WH. Okay, then set P port 1.4 because we have to generate the square wave at port 1.4. Then set P timer run 0. Okay, timer run is 0 is executed. Then loop to jump no bit TF0 loop. So we are watching the TF0, is there any bit present or not. If it is become 1, then the loop will break, it will execute next instruction, clear 1.4, clear TR0, then clear TF0, then L jump loop 1, long jump to loop 1 again. Okay, so this is the program that is used to generate the square wave. Here the square wave generated by the set P at 1.4. Okay, next one, the mode 2 programming. Write a ALP to generate a 2 kHz square wave in pin 1.3. Use timer 1 auto reload mode. Assume crystal frequency is 12 MHz. So initially crystal frequency is 12 MHz, that is divided by 12, that is clock frequency is 1 MHz, that is converted into time, that is 1 by f, that is equal to 1 microsecond. Then square wave frequency is 2 kHz, that is given in our problem. So t square equal to 1 that is 1 divided by 2 10 power 3, that is equal to 500 microsecond. Okay, 500 microsecond. So 50% duty cycle means you divide the 500 by 2, that is equal to 250. Then count equal to time period for square wave divided by time period for clock. So 250 microsecond divided by 1 microsecond, that is equal to 250. Then count value is at 250, so that is subtracted from FFH. So that is FF equal to 256 then minus 250, that is equal to 6. So here we are going to say the T mode register, and then the T mode register set to 20H, that is a 20H. How it is 20H? That is a mode 2 timer 1 is used, mode 2 auto reload mode is considered. Okay, timer 0 is all the zeros. So here we are having timer 1 mode 2 auto reload mode. So then we have to write the program. First we load the 20 to the time T mode register. 20 is T mode register. Then we are moving TH equal to 06. What is 06? That is a count value where TH count is calculated here. That is a 06 is loaded into TH1. Okay, that is a 1 indicate the timer 1. Then set P TR1. TR1 set B means timer run is initialized where timer is started by set B. Then we are checking the flag register whether jump no bit JF1 low. Okay, so if we are checking continuously the flag register, if the flag register value is equal to 1, the loop will break, then it will execute CPL 1.3. okay, clear TF equal to 1, then yes jump low. Okay, so it will generate some square pulses at port 1.1. okay, right, 1.3. sorry. Next one, the counter programming. This is another one mode of the timer. So C by T bar equal to 1 means it is act as a counter. So it will count the external signal that is connected to the port 3.5, that is at T1. Okay, and the value, the another one port is connected to the LCD or LED that indicate the value of incoming clock signal. So the program is write an ALP for counter 1 in mode 2 to count the pulses and display the state of the TL1 count on port 2, assuming that clock pulses are fit into pin 3.5. in the pin 3.5 we give clock pulses. So how we write the program? So just get the clock pulses at pin 3.5 and count the values. That value is displayed in LCD or LED screen. So here the program is initially initialize a T mode register, that is by the T mode is counter 1 mode 2, so C by T bar equal to 1. So this is the data for T mode register 0110 0000, that is a binary number. Then after that T gauge value is loaded by 00, that means the T gauge value is cleared. Then port 3.5 is set, make T1 input. Okay, port 3.5 is set. So what is port 3.5? That means assuming that clock pulses are fit into port 3.5. So port 3.5 is enabled. Okay, that is the input. Then set B timer run 1. Start the timer. TR means timer run 1. By setting the TR1, then the timer is started. Then second loop is started here. Then move a TL1 value. So get copy of the TL1 count. Then move P2 comma A, port 2A. So that get the value of TL value and that is loaded into port 2. And the port 2 is connected with LCD or LED, so the data are displayed in LCD or LED. Then jump no bit TF1, then loop 2. So if then again we are continuously monitoring timer flag 1. If it is 1 means, if it is 0 means it is wait until become 1. Okay, at the time it will generate some background work. Okay, when it is 1, when JNP the TF equal to 1, at the time this loop will break and it will execute clear TR1, clear TF1 and yes jump loop 1. Okay, so here this counter mode count the pulses that is coming from external pin 3.5. okay, and it is the value is stored here, and whenever the become overflow, it will generate the interrupt. So the T, actually here the TH value is copied, okay, right, that is what is here. TL value is copied from the copy to accumulator, that is displayed on the registers, okay, right. So this is the timer programming. So sometimes in a university they will ask the timer programming related questions or 1 mark. So just refer the book and understand. If you have any doubts, please free to call me, okay, right. Thank you. So thanks for watching. So please like, share and comment. Thank you.